Hey guys, just wanted to make a quick video for anyone who is absent over 4.4 because we talked about how to graph a rational function. It's kind of important. It's 1/4 of the entire chapter, so wanted to, instead of just copying the notes, wanted to kind of walk you through things. So this is an example of a rational function, and again, I've got kind of a step-by-step process, so if you just follow this process, you're going to be fine. The very first thing you want to do is, if you're given a rational function, you want to factor both the numerator and the denominator to get an idea, first off, to see if there's anything that's going to cancel, but also to figure out where your vertical asymptotes are, like what your domain is. So this one, I could put it here in the box. I'm just going to put it right here. So the numerator factors into x plus 2, x minus 2. That's the difference of squares. Denominator factors into, well, let's see, x and x. And then I need factors of -4 that add up to +3. So -4, it's going to be 4 and 1, but I need the 4 to be positive and I need the 1 to be negative, and that will give me my +3x in the middle if you do your outer and your inner. So what do we got going on here? So nothing cancels, so that's it. You need the factored and the non-factored form. Both of these versions are going to tell you things about the graph, okay? And so that's going to be important. So step 2, now that we've got it factored, locate the vertical asymptotes. So -4 and +1. So x equals -4 and +1. That's going to be where my vertical asymptotes are. And honestly, if I was doing my homework, I would go down to my graph, and I would graph those. These are two vertical lines, so -4 and +1. Okay, now what these are going to do is these are going to chop our graph. Remember, you can't cross these. So there's going to be a part of our graph that's over here on the left. There's going to be a part of our graph that's in the middle. And then there's going to be another part that's on the right-hand side. So our graph is literally, every time you draw a vertical asymptote, you're dividing your graph into pieces. So there's going to be 3 distinct sections when we go to graph this. Okay? So there's our vertical asymptotes. Number 3 says locate the horizontal asymptotes. So first off, remember, these two this denominator right here, these two factors, that told us where our vertical asymptotes were. Now we're supposed to find the horizontal asymptotes. Well, that's what these things out front do. Remember, all you do is you compare these two exponents, but you want to look at your original function before you factored it. So x squared over x squared, those are the same. That was rule number 2 that said that pretend that they cancel each other out, and you're just left with the number out front, the 1 over 1. So y equals 1 is going to be our horizontal asymptote. So again, I like to just go ahead, go down, and I'm going to draw that. Okay, so again, this is going to tell us what happens as we head towards infinity. So either our graph's going to come from the top and it's going to curl down, or it's going to come from the bottom and it's going to curl up, but it's going to get closer and closer to these dotted lines on the ends. Okay, step 4, locate the intercepts. So I've got x-intercepts and I've got y-intercepts. Well, the x-intercept is anything that would make your function 0. And the function is 0 if the numerator is 0. So 0 divided by anything is 0. So these two, the zeros of our numerator, which in this case would be -2 and +2, these are our x-intercepts. Your y-intercepts are what you get when you let the x's equal 0. If I plug x's in for these zeros right here, I would just get -4 over -4. These two constants on the end dividing each other, that's your y-intercept. So half your information comes from the factored form, half your information comes from the original form. So they're both important. So my x-intercepts are going to be -2 and +2. So those are points. So -2, 0, and +2, 0. And the y-intercept is going to be -4 over -4, which would be 1. So that's the point 0, 1. And so now let's plot this. So -2, 0, down here. +2, 0 is right here. and then 0, 1 is right there. So that's all I got. I got this y-intercept, I got these x-intercepts, but I also have the fact that my graph is not allowed to cross my vertical asymptotes. Okay, so what do we know about this graph? Now, this is it. This is all we know. But there's actually some sneaky things we can figure out. But let me tell you this right now. If you want to know, just like when we did piecewise graphs, if you want to know what is going on over here, then just do a t-chart for our original function using these x values right here. So I could plug in a -5, a -6, a -7, and I could get some dots, some points, that would give me an idea of what this graph's going to do. Same thing here. Okay, I know what happens when x equals 0. I know what happens when x equals -2. But I could do a little t-chart to figure out maybe what happens when right here at like 0.5. That may be important to me. What happens at -3? Okay, I may want to know that as well. And then over here I could do a little t-chart that tells me what happens over here. Now, I kind of have an idea of what happens over here, and let me explain it to you. Again, t-charts always work. Always, always, always. So don't be afraid to do this. If I want to plug in a 3, if I want to plug in a 4, if I want to get really close to this 1 right here, if I want to put in a 1.1 just to see what happens. But let me tell you what's going to happen over here. The fact that my graph goes through this point and is not allowed to cross the vertical asymptote and follows the horizontal asymptote as my x values get bigger and bigger and bigger tells me what this graph's going to do. This graph is going to curl up and start to follow the horizontal asymptote. It's going to curl down and follow the vertical asymptote, and it's going to get trapped by those two dotted lines. So just that one point, but also knowing what happens at the asymptotes, that tells me kind of what the graph's going to look like. Okay, same thing over here. The only thing I know for sure is that these 2 points are going to connect. Okay, so this is like it's curling up a little bit. But then what's going to happen after the point? Well, I'm starting to head towards an asymptote. So the graph is going to have to curl up and follow that vertical asymptote towards infinity. Now again, I crossed the horizontal asymptote. That's okay. As long as it happens in the middle, that's not a big deal. Okay? But then what happens over here? Well, maybe this is a case if you're not certain, is the graph going to curl down? Is it going to turn around and curl up and look like a parabola? Well, maybe this is a case where you want to take this point, so this is -3, and actually plug it in. You can plug it into this original function, so -3 squared would be 9. 9 minus 4 is 5, so it's going to be 5 over, and then what do we get? If we put, again, -3 there, and we're also putting a -3 here, so that's going to be 9. That's going to be -6, so now we're at 3, and then we're going to subtract another 4, so now we're at -1, so it's 5 over -1, or -5, okay? So when you get to -3, your graph is going down. Here's -5. So there we go. It curls down and starts to go that way. Okay, so that's what the middle part of the graph does. Okay, and then, well, what happens over here? We don't have anything. Okay, we don't have any points. But also, not having points tells us something. Okay, this is the x-axis. If we were to cross that x-axis, then we would have discovered an x-intercept. The lack of an x-intercept tells us that we are never going to cross this line. So our graph must be trapped up here. Our graph is going between this horizontal asymptote, that vertical asymptote, and is getting trapped in this little area up here, and that's why it never crosses the x-axis. Okay? So I wanted to kind of walk you through the first example. On the second page, okay, this one, again, vertical asymptotes, I factored everything. Now this one, I got a factor that was going to cancel. I factored the top, I factored the bottom, and I got this factor right here that was common, so they canceled. So that's not a vertical asymptote. That's a hole. I plugged that x value, 2, into the remaining function to figure out where that hole is, and it's at 3/4. So the point 2 3/4 is a hole. The line x equals -2 is a vertical asymptote, so there's my vertical asymptote. There's my hole. A hole's just like a point. It's a place where your graph is going to and then coming out the other end. I also found my horizontal asymptote. Well, this was an x squared over an x squared, so that's just 2. There's my horizontal asymptote. And then I found my x-intercept, which is just what would make this 0, which is 1/2. I found my y-intercept, which is what you get when you let these x's equal 0. So that's 2 over -4, which is -1/2. I plotted those points. So there's my x, there's my y. And then I connected these dots. I followed my asymptotes. I kind of got trapped by my asymptotes here. I got trapped by my asymptotes here. Again, if that's not good enough, if you don't like this whole idea, you want some points, then just make yourself a little T-chart. Plug in these x values like -5, -3, -4, -5, -3, -4, -5. Plug them into the reduced fraction. Make your life easier. Okay, and that'll give you some y values so you can connect those points right there. Okay, but this is what that graph looks like. And then for example B, I wanted to give you one that had an oblique asymptote. So this is x squared, this is x, so this is 1 bigger than that, so this is going to be an oblique asymptote. So the vertical asymptote, that's just x can't equal 0. There is no horizontal, there's an oblique, so I came over here and I had to do that long division. So I took x squared plus 3x plus 2. I divided it by x plus 0. I went ahead and added the constant that wasn't there. And then I did the long division, I got x plus 3. So that's my oblique asymptote. So this dotted line goes through the y-axis at 3 and has a slope of 1/1. So I went up 1/1, up 1/1, up 1/1, and I made that dotted line. So there's my vertical asymptote, there's my oblique asymptote. I found my x-intercepts, -2 and -1 were my x-intercepts. There is no y-intercept because your y-intercept would be what you get if you let x equal 0, but we're not allowed to let x equal 0. Okay, so that's why the y-axis is a vertical asymptote. I plotted my intercepts that I knew, and again, I just used the fact that I knew my graph had to get trapped in between these asymptotes. I know that I don't have any x-intercepts over here, so my graph can't be down here. It can't get trapped this way, or it'd cross right here, so it must be getting trapped up here. And if, again, that's not good enough, do a little T-chart, plug in values like 1, 2, and 3, and you'll get this curve right here, and then you'll know what that graph's going to look like. Okay, so just wanted to do a quick little summary of our 4.4 notes. Thanks, guys.